optimization. Okay. Now let us see what is this optimization. The word this derived from the Latin, that is optimus. The meaning for this one is the best. The optimization characterizes the activity involved to find the best. Now let us see what is this optimization. It is the mathematical discipline which is concerned with finding the maxima and the minima of functions, possibly subjected to the constraints. Optimization is the act of obtaining the best results under given circumstances. It is a part of the mathematics. Within that part of the mathematics, it is a part of the operation research. Within that, it comes under this optimization. Let us see the few fundamental basic concepts related to this optimization. In this, generally we come across the word that is called objective function. This is the heart of the optimization problems. Each and every problem should and must have this objective function. This is the quantity or quantities that you are trying to optimize. It is sometimes referred to as a target. And optimization variables, these are the variables you can change in order to achieve your optimum solution. Coming to the concept of this minimization and maximization, these are mainly depends upon the type of the problem you want to solve. If you want to get the more profit, there in that case you'll think for the maximization. If you want to reduce the wastages in an organization, we'll think for the minimization. That in the sense that mainly this minimization or the maximization are simply we used to call as the optima. The optima may comes under the minimization or maximization, that depends upon the type of the problem. Now let us see this maxima. Maxima is some operation optimization problem. You seek to make the objective function as large possible. Such problems are maximization problem. Similarly, coming to this minimization, is some applications in optimization problems will seek to make the objective function as small as possible. Such problems as minimization problems. Apart from this, we will come across the few more constraints. These are called the explicit constraint. Explicit constraints describes those items that clearly give to you as goals during your optimization process. Let us see the few examples. Limitations of resources, materials and labor. These are comes under this explicit constraints. Coming to the another constraints, it is called the implicit constraint. Implicit constraints refer to those quantities that you must recognize are also constraints on your optimization problem. For this, you can see a few suitable examples for this. Optimizing company's profit by producing different quantities of different goods. This comes under this explicit constraints. These implicit and explicit constraints also depends on problem. Problem to problem, the lot of variations will come across. Let us see this optimality criteria. In this, two questions in generally arise while going for this optimality criteria. One is a static question and another one is a dynamic question. In the static question, we'll see how can one determine whether the given point x is an optimal solution or not. Coming to then the dynamic question, if x is not an optimal point, then how does one go about finding a solution that is optimal? Okay, and these dynamic questions make us to think about the different solution methods that will be adopted to get the solution to a problem. General idea of this optimization, either to minimization or two ways, that is maximization or minimization. In case you are looking for the highest point, that is related to the maximization. In case if you are looking for this minimization, if you are looking for this minimization cost of a cost, then it is called a minimization. Okay, now this optimization theory finds ready application in all branches of engineering. In basically the four primary areas. One is the design aspects of the components, irrespective of any type of any engineering, and planning and analysis of existing operations, and engineering analysis and data reduction and control of dynamical systems. Okay, that in the sense we'll use this optimization to obtain minimal cost, maximum profit, best approximation, optimal design, optimal management or control. Okay, now let us see a few examples related to this. What are the different kinds of general problems and generally we come across in this optimization? First one is, let us take one example of the optimization problems. In these problems, we broadly divide into without constraints and with the constraints, where the constraints is also be referred to as the limitations. Sometimes it is also a term as a conditions. Now let us take one example of the generalized statement. It's like, just I'll make a general statement like go to Delhi. My objective is go to Delhi. If I ask a person to go to Delhi, and it will raise a few kinds of questions in our mind. That is, how to go to Delhi, by what means you have to travel, and when, by what time you have to reach, and when we have to reach. These are all the things comes into the mind. But simply if you state go to Delhi, a person may be going to Delhi today, going to Delhi tomorrow, going to Delhi after 1 week, going to Delhi after 1 month, or going to Delhi within a year, going to Delhi after 10 years, or before kicking the bucket. That in the sense for a optimization which is having no conditions or limitations, there is no certainty of getting the solutions. You may or may not be getting the solution at all. Similarly, these are the things in generally we come across when we think about getting a solution to a unconditional statements in a optimization. It is very difficult to get the solutions within the time, and there is no guarantee of getting the solution. Now let us take another small example for the another generalized statement, that is go to Delhi, and I want to give one constraints, that is I'll give 10,000 rupees to him. I'll give 10,000 rupees and ask the fellow to go to Delhi. But I am not giving any further instructions, only these two statements. Go to Delhi and I given only 10,000 rupees. Spend, let us just add another thing, spend less than 10,000 rupees. In this case, a person may be going to Delhi by thinking about what are the means are there, traveling means, and that should also cost less than 10,000 rupees. That in the sense we in this problem as compared to the previous problem we added one constraint, that is the amount should be spent less than 10,000. That in the sense he may choose either by using travel, train, or he may be going by bus, or by he may be going from here Hyderabad to Delhi by using some four-wheeler, or he may be going directly a flight, or he may be going from Hyderabad to this Ahmedabad, or choosing the different routes. Up to there, he may be going to the by flight. From there, he may be going to the train, or directly he may be starting from here to train, and he will be reaching. That in the sense, within the constraints, what are all the possible ways are there to go to the Delhi? He may try. But here we have not given any conditions by what time he should reach the Delhi. Similarly, as we had a discussion in the first case, he may be reaching the Delhi today, he may be reaching the Delhi tomorrow, he may be reaching the Delhi within a week, within a month, within a year, or he may be reaching the Delhi before kicking the bucket. Okay, now I add for the same problem another condition. That is, first I'll give objective, that is go to Delhi. From then I'll add another constraints 10,000 rupees, and you should reach another statement. I'll give constraints within a week. That in the sense there is a certainty is there in this problem. You can see within the week only he will be reaching by any one of the means, either by flight or by using train or any other vehicle, etc. That in the sense in this problem, if you see observe clearly, three different only the one objective is there for a problem of optimization, but reaching to the Delhi is the objective, but depends upon the condition the output we are getting change. That in the sense in an optimization problem it may be having only one objective function, different one objective, one constraints, two constraints, more than two constraints. Based on these constraints the output of the problem also changes. Okay, these are the fundamental things. Simply we have to remember the basic idea about this optimization. Now let us see where we can apply these optimization techniques. Okay, now we can see it can also be used in civil engineering. Okay, it can also be used in the designing of the frames. It can also be used in the water resource patterns systems, design of optimum pipeline workings. That in the sense we can see a wide variety of applications in different fields of engineering. You can also see few more, that is finding a optimal trajectory of space vehicles. It is not restricting only should be used only in to a particular field of engineering. And optimum design of linkage frames, gears, machine tools, and other mechanical components, and the selection of machine conditioning, and designing material handling equipments, conveyors and trucks and cranes. You can also see the application related to the design of pumps, turbines, heat transfer equipments related to the mechanical engineering. Further, you can also see few more design of control systems may be related to the any control system engineering. Optimum design of chemical processing related to the chemical industry, and the selection of site for an industry of any kind of industry, planning and maintenance of replacement of equipments, reduces the operating cost in an organization. Maybe it may be electrical engineering, mechanical engineering, civil engineering, or medical science, etc. Allocation of resources or services among several activities, to maximize the benefit, controlling the waiting and idle times in production lines of any a organization. You can also see few more applications, planning the best strategy to obtain the maximum profit in the presence of a competitor in comparison and competing with others in the fields and designing the shortest route to be taken by a salesperson to various cities in a single tour, optimal production planning and controlling and scheduling, analysis of statistical data, and building empirical models to obtain the most accurate representation of the statistical phenomena. Apart from this, we can also see in aerospace applications, in electrical machinery, motors, generators, transformers, etc., and the optimal location of telecommunication towers, etc. Here, the listed few of them. There are so many in number of different applications that are existing. Different authors referred so many applications. Few of them I have listed here. Wherever the more than one solution that are existing to get the best of the best solutions, there this optimization is applicable. Now let us see a few fundamental aspects of this mathematical basic that are to be required for this optimization. First one is, let us see what is a function. Okay. Now you can see a function is the mathematical representation of a generalized problem statement that is representing with a common variables that are representing with the of your choice. Here in this slide, just I have shown a variable that is x. The x value may be changing from 0, 1, 2, 3, 4, 5, etc. Depending upon this value of x, the output of the function value changes. For different values of x, different output comes for this function. Okay, that in the sense assigning every value of x a unique value. If you are giving a corresponding unit output, you will be getting for this. Okay, and whatever the values that are giving, okay, if the function is set to all possible input, what are all the possible inputs are there corresponding to that, the positive corresponding output will be getting within the given range of the values. Now, let us see there's a few more points related to this function. In this case, unconstrained and constrained functions are there. Just now we had a discussion about the example of a reaching to a Delhi. That is a unconstrained problem statement. Go to Delhi, reaching the Delhi with spending 10,000 rupees. One constraints, go to Delhi with 10,000 rupees within a week, within a month, within a year. Added another constraint. Okay, now that in the sense in the first statement of the problem related to the unconstrained when the domain is entire set of range of values, constraints domain appears to a subset of R. A function may be a continuous, discontinuous, or discrete. The methods or methodologies that are used to solve for continuous, discontinuous, and discrete methods are completely different. Further, we can also see the functions. A function may be a unimodal function. In this, for unimodal functions further have been classified into monotonic and unimodal. In this monotonic, it is derived into two conditions. That is a monotonically increasing function, monotonically decreasing function. If this is the kind of the function that are existing, it is not at all possible to get the optimal solutions. because in this unimodal functions, unimodality, it is not possible to get the optimum solutions. To get the optimum to any function, one of the basic property that is required is at least at one point the derivative of a given function should be equal to 0. If that is existing, then only it is possible to have a optimum solution to a function. If that is not existing, if that property is not possible with monotonically increasing or monotonically decreasing functions. Monotonically increasing functions and monotonically decreasing functions. We can see the monotonically increasing function, monotonically decreasing function. But for a unimodality function, a unimodality function is a function which is having only one optimum within the given limitation. So you can see the unimodality function over here. Let us assume that it is having the range and the limitations. It is having only one optimum. That in the sense, this is a point at which the derivative of a given function is equal to 0. That in the sense, it is one of the basic property. A function may be having one or more than one optimal points, or simply we can see the derivative of a given function may be 0 at one point or 0 at multiple points. A function may be having a function with only one optimum value or more than one optimum value. If it is a function is having only one optimum value at one particular point, then it is called within a given range or limitations, it is called a unimodal function. If a function is having more than one optimal points, then it is called a multimodal function. It may be called a unimodal function or multimodal function. You can see a unimodal function within the range A and B. Only one optimum is existing, that is the maximum. Let us take multimodal function between the range A and B. Here maximum, maximum, maximum. 3 optimals are existing. Another 2 minimas are existing. Out of 5 optimas are existing. Out of 5, 3 are the max and 2 are the minimum. A function which is having only within the unimodal function, only one optimum is existing, either it is a maxima or minima. In multimodal function, it may be having the more than one minima or more than one maxima or combinations of minima and maximas. Okay, then further in this aspect, another point we will come across, that is called the global optimum and local optimum. A function which is having the optimum value, which is having the most optimum either in terms of maximum or in terms of minimum, is termed as a global optimum. Let us take example from this. Point A is greater than that of C and E points. This is the global maximum of a given function. Similarly, if you see here in this B and D, B is the most minimum. It is called the global minimum of this function at point B. But coming to this unimodal function, it is having only one optimum. It will be treated as itself is a local and as well as a global. But coming to this in multimodal function, the global may be local. If you restrict to such a area to up to a certain limit, then it becomes a local optimum. Okay. Now, let us see a few more aspects about the classifications of the broader classifications of these objective functions. Based on these characteristics, number of control variables, unvariable, more than one variable, univariate and multivariate. A type of control variable, continuous, real numbers, integer. Classification is a continuous function, integer or discrete function. Both continuous and real, that is called a mixed integer. And the problem functions, linear functions, we will be having the linear objective functions. For quadratic functions, we will be having the quadratic objective functions, and the non-linear will be having the non-linear objective function. Problem formulation, this is subjected to the constraints, constraint optimization, and not subjected to the constraint, it is a non-constraint, unconstrained optimization problem. And in this video, I will be stopping here the fundamental aspects of this optimization, and that is up to this objective functions. In the next video, we will be continuing the further extension to this optimization. And thank you to all.